welcome everyone. My name is Nadia and I'm from TMLS. So welcome to this first day of workshop at TLMS 2020. Today we have a special speaker, Pooja Bhojwani, that she's a senior machine learning engineer and mentor at Scotiabank. And she's going to guide us through leveraging pre-trained language model for natural language understanding. Please keep your mic off so that Pooja can run her workshop without impediment. So welcome, Pooja, and let's start.
Thank you. Thank you, Nadia. Hello, everyone. I hope you guys are excited for your first TMLS workshop at TMLS, and I hope you have a lot of fun in the next 2 hours. As Nadia pointed out, it would be helpful if you all can just mute yourself and turn off your videos. I'm going to start by sharing my screen. And the way we are going to communicate is through Slack. So I'll give you the link in a bit. Let me just start by sharing my screen. Okay, so today we are here to learn about leveraging pre-trained models, language models for natural language understanding. And if you guys are familiar, yep. So if you're familiar with natural language understanding, it's basically the art and science of helping machines understand the human language. And we're going to do that through we're going to do some hands-on using pre-trained language models, and we're going to fine tune it for our specific tasks and all. So let's get started. Nadia already introduced me, so you already know. We have a guest here today with us, Danush. He's gonna help with answering all the questions. So if you can the next, I'm gonna share the link, Slack link. If you can download Slack, we'll have we have a separate channel there for questions. And if you have any questions during the workshop, just post it there. Don't worry about it. It will be addressed as soon as possible, either by me or by Danush. Okay, so if you guys are familiar with the traditional natural language processing cycle, it basically involves language detection, which starts with tokenizations, POS tagging, that's basic pre-processing steps. And then for modeling part, we usually do feature extraction, modeling all by ourselves. And then we train it for specific tasks like sentiment classification or entity extraction or translation. So what we're going to learn about today is deep learning based NLP. And so what happens is you still have to do some pre-processing, but most of the steps, the feature extraction modeling part is it's a bit abstract now. It's layered for you. You don't have to go into too much details, but you should know about it. And then we will fine tune it for we can fine tune it for different tasks like sentiment analysis or entity extraction, translation, anything. One more thing I want to point out is for every slide, I have listed a link, which is here, the source is the YouTube link. So if you want to know in detail about anything, each slide has this link. So if you go there, it will be like a beautiful explanation or in-depth explanation about that particular thing we are learning. So next we can start by doing the setup and guidelines. So I'm just gonna copy this. Okay, let me just. So I'm gonna copy the Slack channel and post it in our Zoom chat. Okay, here we go. So you should get a link to this Slack channel, and I at this point I ask you all to join this channel, which will be used for sharing all the material for workshop and also for asking questions. And I'm gonna wait for a few minutes and let you guys download this. Well, we can do it here, but in Slack, we just have different rooms, like different channels, like general, class poll, questions. So it will be much easier, like it's better organized. I see some of you have already joined. So if you are on the Slack channel already, like on Slack already, you can see some channels like classroom poll and questions where you can just post any questions you have during any point of the presentation or when we are doing hands-on, even if it's a technical difficulty, we'll be there to like help you solve that. Okay, so I hope everyone's done by now. If you're not, just like post in Zoom that wait for me. I'll wait for you guys. But if I don't hear from anyone, so next I'll ask you guys to go to the channel general. You should see like 7 files there, which includes one of the file is the presentation which I am presenting here right now, and there are some notebooks as well, which you should upload to Google Drive. And if anything's not working or if you have any questions about the setup, just post in the questions channel. Hi, Danielle. I see your question, what you're downloading and why. So this is the notebooks which we are gonna go through during our presentation. We're gonna do some hands-on on that. So just go to the general channel. If you like, I have attached 7 files there. If you guys don't see it, just let me know. I will reattach them. And highly encourage everyone to like do this setup because it will be really easy for you if you walk through like the material with me and you run the notebooks yourself rather than just seeing me running them. It will like give you hands-on experience and yeah, it'll be fun. Finally, if you're done with the setup, in the channel classroom poll, I have set a poll. Did you finish setting up? So if you have done, just click on all done. Else just click on not yet. Wait for me. So I see like two people have already done the setup. Thank you, Nadia and Avishai, to let me know. If any of you guys just joined, what we have done so far is we've shared a link of Slack that's on the Zoom chat. Everyone's on Slack now, and we have a channel for doing the setup, downloading files, and like getting the notebooks, which we'll be using for hands-on experiments today. If you're not yet on Slack and you have questions, just post on Zoom. Sure, Michelle. Here's the link to Slack. So really the aim of this workshop is to have as much fun as you can and learn along with it. So if you have any questions at all, don't hesitate to ask. That's why we have a separate channel. We have guests, someone helping us. So yeah, so I'm just gonna check the classroom poll. Okay, 5 people are done. I'm gonna give it like 3 to 4 more minutes and then we'll start. Okay, so while you guys are setting up, I can go through some slides. So really we have gone through the guidelines. You are all muted. If you have any questions, you can post it on Slack. And when you're done with any of the hands-on or the task which is given, we'll create a poll in the classroom poll channel. And if you're done, just let us know so that we can proceed. This like the online thing can be like bit hard for both the participants and the presenter, but we have tried to make it as easy as possible. So let's get going. We'll come back. If you have any questions, if you're not able to set up, just post either in Zoom or in Slack. We'll come back. So we're gonna start with language modeling. What exactly is language modeling? It is the art of predicting the next word. So for example, the student opened their dash blank. It can be books, laptops, exams, minds. So the art and science of predicting this next word, that's exactly language modeling. And there is a beautiful, what do you call, like a course by Stanford CS224N, which is basically about language modeling. It's called deep learning using NLP, and it covers everything from start to scratch. So if you are more interested in knowing after this workshop or in general, then you can go there and study about it. So here's the evolution of language modeling, or like NLP in general. So if you are familiar with traditional NLP, you're probably familiar with bag of words, TF-IDF. If you're not familiar, that's okay too, because today we are gonna focus on transformer models and specifically BERT. So why focus on pre-trained models? Why is this workshop called leveraging pre-trained models? Why is it not called leveraging, like training the BERT model from scratch or something, right? So the reason is right on the screen. If you can see my slide, basically the models which are pre-trained, they're trained on like huge data set, and their training volume is pretty high, and the cost to do this training, to train on so many parameters, billions of parameters, it costs a lot. So it's not like affordable. So there are practically there are just two ways to go about it. One is directly use the pre-trained model, or second is fine tune it to your specific task. So we're going to go through both of these cycles in our workshop today. We're going to use the pre-trained models directly, and we're also going to fine tune it for our task. So here are some common language models. I should have listed BART, which was developed by Facebook as well. Basically, we are going to learn more about BERT. Distal BERT is, again, it's just like applying, you can call it as a lighter version of BERT. So yeah, I forgot to mention that most of these models, so all this advancement has happened after we got the transformer architecture. So we're gonna have a look into like an abstract view of what exactly a transformer is. So this is at a very abstract level. And if you want to go into details, I've listed the link there. Jay Alamar, he explains transformers in details beautifully in this article, which you can access. There's a link on this slide. So basically, a transformer structure is a package, you can call it, of encoder and decoder structure. And the encoder structure can be broken down into like self-attention, which is going into feed forward, and decoder structure has self-attention, and then the encoder decoder attention and feed forward. So encoder decoder attention, this particular part, it comes from the encoder, and it contains the information from the encoder, and this helps the decoder to focus on specific part of the text or the information it's getting. So that's like a basic transformer structure. Now you must be familiar with the feed forward network, which is basically a neural net which doesn't form a cycle. But what exactly is self-attention? All the fuss up, like all these advancements, they all came after this thing called self-attention. So this is like a very abstract, or like a basic understanding of how like what exactly the self-attention does. It basically it's a method of capturing importance of other tokens in the current token. Okay, by that, what I mean is, read this sentence. The animal didn't cross the street because it was too tired. So what does it here refer to? It refers to the animal. It's clear to us, but it's not clear to the machine, right? So using self-attention, what we do is we pass this information. So we pass that, hey, if you are talking about it, you're probably referring to the animal. So you're packaging all this information, like the what do you call, you like packaging, or like binding the information about other words, importance of other words, to the current word. So that's the gist of self-attention. So now, since we have a basic idea of transformer, we have a basic idea of self-attention. So what exactly is BERT? Surprisingly, BERT is just like trained transformer encoder stack. So architecturally, it's not different from what you have already seen. It's just like bunch of encoders stacked on top of each other. And in each encoder, like we have seen here, let me just go back, it has self-attention and feed-forward. So what they did was they just said, hey, we're going to take the encoder part of the transformer and we're going to use that to do something for natural language processing. So that's the gist of BERT, trained transformer encoder stack, right? And there's like a BERT base and BERT large, which is basically, there's a difference in the number of layers or number of encoders each of them has. Yeah. Yeah. So of course there are some differences. The difference is like BERT is trained on a huge data set, and also it is trained for two specific tasks. One is masked LM, which is masked language modeling, and the second is next sentence prediction. So what exactly is masked language modeling? It's basically like, so the idea is to mask 15%. Now this is a percent which they got like after experimentation. So what they do is they just mask 15% of the words and they train the model on it. And the task, like after the transformer encoder, the output goes to a classification layer, which basically tries to get the probability of W4 here being something, right? So it tries to predict this word. And the loss function here is not like, the loss is calculated not on the unmasked words, it's calculated on the masked words. So why are they doing this? They're basically doing this in order to like capture the context of all other words or all other like all other words in the sentences into this word W4. Like based on the context, what should this word be? So that's how masked LM or masked language modeling is done. Like BERT is trained on masked LM. The second task which BERT is trained on is next sentence prediction. So the input here, as you can see, is my dog is cute, he likes playing. So one of the key points to note here is play is divided into play and playing. This is basically tokenization. We'll look into a bit more detail, and you can see like CLS, SEP, right, in input token. So CLS and SEP, these are these specific, you can call them as special tokens, which BERT needs to identify whether it's the start of the sentence or end of the sentence, like it's just like a separator, and that is the start classification, right? So the way next sentence prediction works is sentence pairs are fed to the model. So they form pair of sentences, and 50% of the sentences are like actual pairs. So my dog is cute, he likes playing. That's like an actual pair. Another example can be my dog is cute, I live in Toronto. They don't make sense. It like the following sentence is not actually the next sentence. And the task which the next sentence prediction performs is if the following sentence is actually the next sentence, right? And the way it does is just simply a classification task to predict if the following sentence is actually the next sentence. And the way BERT is trained overall is masked LM and next sentence. It's trained on both the tasks parallelly, and the loss is calculated is the way loss is calculated is they want to maximize or like minimize the loss on both these tasks parallelly, right? So that with that we have covered basics of language modeling and how BERT is trained. I see some questions, I'll get to them because they're about setup. So we'll be like starting hands-on soon, and I'll have a look at the questions section. Next is application. So you're gonna love how many applications we are gonna, like how many tasks we are gonna perform using pre-trained models today. So here's a list of all the applications. So we'll look into details of each of them, Let's start with named entity recognition and question answering. So the way we are going to do it is I'm going to talk about NER and QA. Once we are done with that, we'll switch to hands-on. And I hope like you have the setup done by now. If not, we can take a minute, pause and see like if everyone is on the same page and start. So once you're done with hands-on on these two, then we'll have a look at all other tasks. Right. So NER, what exactly it is? Some of you guys are probably familiar with it, some are not, but basically it's extracting words or strings of interest and actually categorizing them. So in the example here, like jobs is a person because Steve Jobs, right? And so we are categorizing like whether it's a person or company, date. You can see this example, and it can be like the entity here is like person, company, date. It can be specific to a company as well. It can be specific to any task as well, right? These are just the general labels which everyone decides to um, tag it with. So now how BERT is fine-tuned to do NER. So we have learned so far that BERT will give you like a vector of all like the output embedding, right? The output embedding is then fed, like if you want to fine tune it for NER, it is fed to a classification layer, which basically will classify if it's an organization or if it's unidentified, miscellaneous person. And you can, of course, you can give these labels yourself as well. Okay, and then I think I'm not very sure, but the tutorial, I think the link I've given here is a nice tutorial about NER using BERT, and we are gonna, like, if time permits, we will also fine tune NER problem using BERT. So we can have a look at that then. So next task is question answering. So question answering is basically like given a text and a question, can you answer? So the condition here is answer should be present in the passage. It should be like a line or a text, like a word or a combination of words, but from the passage. It's okay if it's not there, but it won't like make it up. And how BERT is fine-tuned for it. Basically, we've seen the next sentence classification, right? Like next sentence prediction, whether it's the next sentence or not. So fine-tuning BERT for question answering is kind of similar to that. What you do is you give the question as well as the paragraph, and you see there's a separator. This is like a standard BERT format, how it accepts the input. So there's a separator, CLS, special token, and it's given as input to the BERT. And the output layer, output embedding layer, finally what it does is it has a separate classifier, or it predicts like two positions. One is the start and the end span. So start span basically marks the start of the answer, and end span marks the end of the answer. All right, so we will come back to sentiment analysis, but let's start like doing some hands-on now. Are we all on the same page? I'm just gonna create a poll. Okay, check. If you have done the setup and if you have the notebooks on, can you please vote in channel classroom poll? Okay, so I see there are two people. No, okay, no one said wait for me, so I'll start soon. Finish setting up. Hi, can you hear me? Okay, cool. Thank you, Abhishek. Um, just waiting for some people to vote in if they have finished setting up and setting up the notebooks. I'm gonna then start with intro to transformers. If you have that notebook open in Collab, we can start with it. Just open it up. I'm gonna walk you through the named entity recognition part and question answering. That's what we covered in slides. Okay, cool. Okay, so you should be able to see my screen, like probably you're seeing my screen now, and you probably have this notebook open in Google Colab as well. One thing which I want to point out before starting is if you see over the left here, I have Collab Pro. This is because I had to pay for GPUs, like it's $13 per month, but I had to do it to run, like not right now. This notebook should run fine, but for fine tuning, it was failing for me, and I had to switch to GPUs. See, if it doesn't work, don't bother. If you want to pay for it, go ahead, or you can just walk through the code, right? And if you have GPUs, then yeah, you can use them. Okay, so NER, we have covered the basics about how, what exactly is NER. One interesting thing I want to talk about is Doccano, which is basically like annotating, it's a tool for annotating the data set. And later in the class, in the later half, we will be using that to label our own data set for NER. So that will make it more clear. But for now, let's have a look at what we have here. So we are using both, this tutorial covers both like Spacey model and then using Hugging Faces transformer model. We'll use both of them to perform any task. So here, if you can see, it basically just loads the NER model, and then what we are doing is we are just passing the sequence. So we are not doing any training. We are using the pre-trained model, passing the sequence, and in the end, what we are getting is for each entity, we are getting a tag. So Donald Trump efforts, president efforts to deny the outcome of 2020 election. This is all recent. And here it's tagged, and it comes like this, right? And Spacey has a beautiful visual library, Displacy, which basically renders it, and it you can have the tag here. In your text, it will tell you like what exactly each of the words, which were like, if it was identified word, or I should call it phrase, if it was identified, it will be labeled in your text, something like this, right? So if you're running the notebook, just go ahead and try running it. Feel free to play around, change the text, and then see what comes up, what gets tagged, what doesn't. Yeah, so sorry, one more thing to mention is Spacey just uses, I think, CNNs or to do this tagging. Not very sure, but it doesn't use the transformer. So what we are doing what for the transformer, we're using the Hugging Face library. I absolutely love this library because it, like all the current advancements, they just like have the pre-trained version of the model. It's basically like a Git. I can call it like a GitHub for NLP. So it has all the pre-trained models, has all the notebooks which you can play around with. If you get time and if you're really interested in knowing more, you can just like go to Hugging Face and try some of their already existing notebooks. So first is installing the transformers, which is from Hugging Face. Like this command should work for you. If you're using Collab, right? And then, so Hugging Face has this library called pipeline. So what pipeline does, it provides a next level of abstraction, I would say. So it does tokenization for you. It provides you a tokenization model. It provides you actually a pre-trained model and the task which you can use it for. So here we are just using pipeline, and we're using NER pipeline. We're passing the same sequence. So the Donald Trump one, which is from here, right? Passing it, and then we're finally getting like we're getting the prediction. It's still something. It's not exactly the same as Facey, but we're getting the entity prediction. If you want to have a look at what the model looks like behind the scenes, right? Because this is very abstract, you're just using a pipeline, NER. So you can just call nlp.model, which will give you a list of like all the layers which your model has. So we are just showing this for one of the tasks because it's like a heavy, it has too many layers. It's just like hard to scroll and, you know, so you can do it for anything on your notebook. So that was like a very abstract way of solving a NER problem. What you did was recapping. So you gave a sequence and then you got the tags, the entity tags. Everything like is pre-trained. You don't know what tokenizer we are using or what model we are using. So this is one more example. Basically, it's doing the same thing, but it's less like abstract. It has like we are getting more information. So we are using BERT large case, which is fine-tuned on CoNLL 103, right? And we're using a tokenizer, which is also from there. Okay, so I should take a moment and tell you about Hugging Face has all these models, pre-trained models. So if you go to the library, there's a list called like pre-trained models. You can select any model from there and you can do your experiment provided it's fine-tuned for your task, right? So we just use that. And then we are doing the same thing. So we got the tokens and then we are getting prediction for each of these tokens. Okay, so one more thing about using pipeline, you can actually identify, okay, let me just scroll up a bit to actually show you the difference. So when we used, sorry, what's it? Yeah. So when we use the pipeline here, NER, we did not define any model. We just used this pipeline and whatever model it's using under the hood, right? So there is a parameter which you can pass in the pipeline, which is actually defining the model, which should be passed in to the pipeline. And the way it's done is just you define the model, and again, we are doing the same thing, right? Similarly, you will be surprised to see how many models are available, like just freely available. This one is doing NER on Swedish. I don't know the language. If any of you knows, then you can read it, right? And what it does is it basically gets the entities for that particular task or for that particular paragraph. And it's almost similar, just using a different model which has been tuned for Swedish. Are we all on same page? I see a question, which notebook are we opening? This is Intro to Transformer Models. I'm gonna just type in general so that you all know. Open up. Okay. So after explaining question answering, I'm going to take like a 5 minutes pause and let you breathe in whatever we have studied so far. You can go through the slides, you can play around with NLP and question answering, sorry, NER and question answering, and then yeah, we'll resume. So basically in question answering, we have seen like how it's done. What we are doing here is using distilled BERT. I'm not sure if you remember, but I did mention that distilled BERT is, I would call it as a lighter version of BERT, which is used more often, and that's because it's just lighter. I think it has 40% less parameters, but it's 60% faster than actual BERT. So that's why we are using it here, right? And the squad is a standard data set. I don't remember the exact full form. It's by Stanford, so Stanford question answering something. So that's a data set prepared by them, and we are using already trained, like a pre-trained model, which is trained on squad to get our actual answers, right? And yep, so we are encoding it. If you want to read about each, like if you want to know about any of these methods, just post in the channel, or you can read on Hugging Face. Basically encoding plus, if you remember, we talked about special tokens like CLS, separation, and there are a lot more, like unknown, if the word is not known, right? So all this is like batch encoding plus takes care of that. Actually, let me just show you a slide about tokenization quickly before we move forward. So we are talking about tokenization a lot. What's happening under the hood? Basically, breaking the word into tokens, right? The word is broken, and then it adds these special tokens. That's what they're called, or at least like a lot of blocks call them special tokens. So they're like CLS, separation, if it's an unknown token. And then these tokens are substituted with the IDs. So CLS has 101, that's the standard ID. Separation has 102, and these IDs are like assigned based on pre-training. So that's what tokenization does to your text. Okay, where were we? Yeah, question answering. So what's happening is we like encoded the questions, right? Question answers. Yeah, so once it's encoded, we are trying to like get the score of the start and end. As we discussed in the slides, we will get the maximum like start score and end score, which will basically tell us what's the answer. And here we are just like trying to fetch the string which comes between start and the end, like the marker, right? And then we are converting the tokens. So these ones are the like tokens which we saw in the slide, right? And then we convert it into string. So let's go through the text. It's about COVID, and there's a lot of text which basically talks about symptoms, where did it originate, and all that. And when we try to like our questions are, where was COVID first found? It found the answer. How long does it take for symptoms to show? It got the answer. So all these are strings which you can actually find in your text, right? But it's too much to read, and you can just run it. I mean, this is not too much, but still you can run it through any text and get the answers, right? So one thing you can see here is what are the preventive measures? It was not able to fetch it. The reason why it was not able to fetch it is because it's a big paragraph for our BERT model to understand. So what like people usually do is they break it into smaller paragraphs, or you can call them like smaller set of sentences, I would say, like a list of sentences, smaller sentences, right? So what we are doing here is we're just passing it a small subset of the actual transcript, right? And once, if we do that, we are able to actually get the answer. So that's one. This is just to show that this is like a good practice. If you can give it into small if you can just divide your text into smaller chunks and then pass it to your question answering model, it will be doing better. Yeah. And this is directly using the pipeline as we use for NER question answering, and you get the same, almost the same answers, actually the same answers. We'll call it almost same. Same, you can see the model behind, like under the hood, what is used in like a Hugging Face pipeline. It's a distal BERT for question answering with multiple layers. Okay, so I'm gonna pause for 5 minutes so that you can play around with the notebook. Post, and I'm gonna look at the questions section if you have posted any questions. Yeah. Hi Abhishek, we are not giving the answers to the questions here. They haven't been labeled. We are just, what we are doing is we're just using a fine-tuned BERT and we are trying to pass a text and a set of questions, that's all. And then what it does is it looks at the text and the questions like we saw in the slide, right? And then it finds the answer, which is the start and the end segment for us. Are people still doing regular NLP, or the industry is moving towards using existing models like BERT? Yeah, so hi, E. Molano. So that's a good question. And there is, I've seen like a mix, I would call like a fusion. Some people still believe in like traditional NLP, but like there are some tasks which can be like really improved, or you can say that like you don't have to put much efforts if you actually use deep learning. So I've used like I've seen mixed things. I would say like a startup culture is more leaning towards using the pre-trained models because they don't have much time. And if it's like a well-established organization, they do get to deep learning, but they prefer starting with traditional NLP, see if it works, and if it doesn't, then they switch to deep learning. How closely does the question wording have to match the text? So that answer for this, unfortunately, from my side is going to be very abstract, because it depends. Because like sometimes it's like the way it's trained is it should be able to fetch it if it's closely related, right? Like if you try a random question, or if you try changing your word in a way that it's not able to understand, then it might not be able to do it. So it depends. Yeah. Okay, should look like any questions on transformers or attention. Okay, that's Danish. Okay. So I hope you guys are playing around with the notebook. If you have any questions regarding the notebook, just post it on the channel. I'm here. If any of you are, if it's still like you haven't done the setup yet, that's okay. Just let me know. We can help you. It's okay. You can, like, if you don't want to message in the questions group, you can do a private message on Slack. We'll be there for you. Just want you guys to have fun. I don't see any questions yet. I'm gonna give it 3-4 minutes. So I highly recommend just go through the slides. That's also available in general section, right? There's like TMLS, NLP, PDF. Just go through that. If you have any questions, or if you have any questions about notebook, just post it. For question answering, how do you decide to split the data in order to get an answer that wasn't being found with the full text? Right. So for the example which I've shown you, what we did was we just got the part of text which actually had the answer. And you're right, in the real world, you can't do it. What you can do is you can just split the text, and then like you can ask all the questions in that split text, right? Like you don't have to do it for question specific. It's 10 o'clock. Sorry about that. Yep. So you don't have to do it for specific question. You just like split it into like random chunks, I would say, and then ask all the questions on that chunk. But I do understand that there is like a flaw in this, and the flaw is, what if the context of the question goes in the previous, right, like the previous bucket, and the answer is in the another bucket. But yeah, I don't think there's a solution for that. You just have to split the text at some point. But as long as the paragraph is good enough, like not a bad size, if it's a decent size, BERT should be able to find the answer for you. Sorry, I just joined. Is the link to notebooks shared? Hi, Shimona, no problem. I'm just gonna share the link, Slack channels link. And if you go to the general channel in that Slack group, you can find the notebooks there. Let me just share it with you. 1 second. Shimona, if you have any questions, just post it in the questions group. And if you go to the general channel, you can see the notebooks as well as link to the presentation. So I'm gonna create a poll again, which will basically give me an idea of whether you have tried stuff or you're still working on it. Okay, so if you are ready to move forward, go ahead, and I'm just marking the questions channel for myself and Danish so that we know all questions have been answered. If your question hasn't been answered, just repost. Okay, so I'm gonna start with the slides in a minute. 10:05, we'll just go through rest of the slides. So far, let me just do a quick recap. We were working, like we were seeing different NLP tasks and how to fine tune BERT on them. So like we've just learned about NER and Q&A. For sentiment analysis, what's sentiment analysis? Basically, it's just like you have these sentences and you want to know whether it's like a positive statement, negative statement, or neutral statement. Well, this can be crucial in some cases, like reviews. So if you are a seller or if you have a website, you want to know which products are doing good, which are not. And there are like a lot more applications, of course, right? Like if you can say what's it called, customer care, is that what? Yeah. So if it's like a customer support, you want to know whether your customers are happy or they're sad. So the way it's done is you convert, like if it's a phone call, the speech is converted to text and then you do sentiment analysis on text. So fine tuning BERT for that is again like almost just adding a classifier on top of the top embeddings, right? And then the classifier makes a decision whether it's a positive or negative sentiment, or you can have a lot more labels. You just like fine tune BERT for sentiment classification, right? So for the following tasks, like other tasks, we're just gonna go through the basic standard pipeline, which Hugging Face has already provided. So text summarization. Text summarization is pretty straightforward. You have like a full article, you perform, you wanna get summary or you wanna get like what's important in that text. Some of the applications I can think of is like in finance. If the document is too large and like someone has to actually go through 10 pages, I've personally worked on something like that. So if someone has to go through like 10 pages, and they like, it takes a lot of time, right? So what you want to do is you just want to extract the summary and give to them, hey, this is the important points and you should just focus on that. And luckily, we have a pipeline provided by Hugging Face, which is already trained for text summarization task, and you can fine tune it if you want. Text generation, this is very interesting. So text generation is like, there's a demo. If you just click on the link, okay. So if you just go to complete text, it's gonna write something for you, right? So what it's doing is it's predicting the next word, and then it's taking all the words, including the next word as input, then predicting the next word, and that's how it keeps on going forever. You can you can set a limit. Machine translation is also one interesting application of NLP. So are you enjoying the season so far? I actually typed the session so far, but thank you, Google, for correcting me. So are you enjoying the season so far? So the applications are pretty clear. Cross-lingual translation, this has become fairly easy now. I remember a particular case where like we had to communicate with someone and we didn't know the language, so we just used the Google Translate, and I'm sure you guys have faced same situation. So this is like a neural machine translation is also an application, text to text, speech to text. So next is predicting missing word, which is basically something which we have covered when we were thinking, like we were learning about training BERT, right? So when BERT is trained, it's like it masks the word. That task is basically like, if you give that as task, it's gonna predict that missing word. And in a sense, like this task is not that important, but it's pretty good for like useful for training, because now the hidden word, it kind of stores the context of nearby words. conversation. There's a pipeline provided by Hugging Face about conversation, so you can like provide like sentence A, sentence B, and then you can use the conversation pipeline to get the sentences. And it's this is like we have seen like most of the times when we talk to customer support, we just talk to chatbots. So yeah, you can have your own chatbot up in minutes because you have the pipeline already in Hugging Face. You can directly use that.
Sorry, I'm having trouble hearing you.
Oops, that was my watch. So yeah, that's it, I guess, in terms of applications. And I have already covered like this slide where we are talking about tokenization and how is it done. So let's go back to the Collab notebook. So what I want you guys now to do is you go through these pipeline, right? Like these are pretty straightforward pipelines. You're just using for summarizations. There's a pipeline for summarization. You just give the text, right? And it creates a summary for you and presents you. So if you can tweak around the text and play around and see what it generates, it'll be interesting to see that. The pipeline for text generation as well. So just a quick recap. So pipeline is encapsulating tokenization, it's encapsulating modeling. You can specify your own model, you can specify your own tokenizer, right? So here, model specified as GPT-2. This is like one more pretty interesting model, which is like used for mostly for predicting the next word or generating text. So remember how BERT uses the encoder part of the transformer, GPT-2 uses the decoder part of the transformer. And it does, like, yeah, we won't go into details, but you can read about it. So you can see all these examples of text generation where it has generated text for you, right? So, okay. So summarization, text generation, machine translation. You can use, like there are pipelines available for translation, direct translation. You just feed the text into that. So you don't no longer need to use Google Translate. If you have an application in your work or in your school project where you just want to, like have a small translator as part of the job, you can directly use this pipeline and it will do the translation for you. Or you can fine tune it. But like for translation, it's pretty much available for any language to any language now. Mostly from English to something. And there was a recent advancement where like English was no longer required. It was from language A to language B. So I hope you're like, while I'm just scrolling through the notebook, you're playing around with it. And yeah. So I guess like for this Marian model and tokenizer, I think this is the one which is available for a lot of languages, and you can use it to, to do tokenize, like you do generate text or do anything for, or translation mostly. So here we're translating it, right? And I don't understand what's trying to say, but I do know it's translating it to Roman. Predicting missing word. Here's an example to do that. And finally, the conversation. The conversation one might fail for you guys because I think the notebook you have doesn't initialize this pipeline. I'm not very sure, but I'm still gonna post it in the general section, this line. So you just initialize the pipeline like this, just say conversation pipeline equals pipeline, and then you give the keyword, which is conversation. So I'm gonna give you 5 minutes because we don't have enough time, but I still want you guys to play around with it and ask any questions if you have. Just go through this notebook and try running these cells, try changing the text and see what you get. Next, we are gonna start with fine tuning. When we start fine tuning, you'll see how easy the Hugging Face library has made for us, or how easy it is to like fine tune actually like BERT for your specific task. Is BERT available for NLP in Spanish language? Hi, it should be available. I'm gonna search for it, but I'm pretty sure it should be available. It's available in like 1,000 languages. So yeah. But to be honest, I haven't used it. So yeah. Does text generation have any business application? Is it mostly for fun? Interesting. I was thinking about the same thing yesterday. I was like, we are having fun with this, but like, so it is the base for a lot of other applications, right? But in a sense, I haven't used text generation for any business application. So I guess Danush is back. He's gonna answer all the questions in the questions channel, and I will be focusing on the notebook. Okay, creating a poll again, just to make sure everyone's on the same page. Ready to move to fine tuning. If you're not, I'll wait. Oh, Danush just posted a link for Spanish fine tune, like fine tune model on Spanish. I think someone asked about it. I haven't received any single vote. So if you're ready, just vote in the classroom poll. Oh, where does the other line go? Danielle, it should be before conversation pipeline or conversational pipeline if it's failing for you. So it's basically creating the pipeline. Perfect, thank you, Danielle. So I assume some of you guys are still experimenting. Take your time, it's okay. We will start 10:25. And considering the time, I think we'll do one fine tuning, which is sentiment analysis, sentiment classification. And after that, we'll have a look into Kano, which is basically we'll be using that to create our own NER dataset. Hi, Sui. I'm looking into why your questions are getting same answers. It's funny, but maybe it's a small bug or something. I'll have a look. Okay, so if you are ready, just open the new, like the notebook fine-tuning sentiment classification, which is also shared in general. Just open it using Collab. A small warning, this you might not be able to train it, but you can reach the point of training it, and it might fail during training because of CP, like because it might need GPU. I just switched to Collab Pro for this specific notebook or other tasks. But yeah, you can go through the code, like we'll walk through the code and yeah. And also in this, for fine tuning, we will be using DistilBERT, which is again, what did I say before? It's like a filtered version of BERT, right? Like it's a lighter version of BERT. That's the right of BERT. So let me check the poll. A lot of people, 6 people are ready. Okay, that's good. Okay, so if you're ready, just open that notebook, fine-tuning sentiment classification. I'm gonna start sharing my screen. Okay, just please vote for me if you're not ready, because most of the people have just voted they're ready. No one has said they're not. And I still have just 8 votes. Votes are in classroom poll. Okay. I didn't get, okay, that's fine. We'll move forward. And if you want me to stop, just let me know. Okay, so fine tuning sentiment classification. Most of you guys are probably familiar with this data set. If you're not, just go ahead and click and then it will download the data set for you. It is basically IMDb movie reviews, and it has like positive and negative, right? Like this task, so the review will either be a positive or a negative review. And what we're going to do is we're going to fine tune DistilBERT, which is a lighter version of BERT, for this specific task. So step 1, we download the data, and then we just do a small pre-processing to create like a train and test split. If you're like not familiar with traditional machine learning, basically it's just like you're dividing the data into like you're keeping part of data which you can use later for testing, because that's like unseen data, right? So read IMDb split basically does the split for you, like does the pre-processing for you, and it creates the train set and test set with like text and the labels. And one more key note here, this is a working example which I got from the Hugging Face library. So they have given this example as a custom fine tuning which you can do on BERT. So if you want more details, you can go there as well. Okay, so then we are doing the train test split, getting the validation data, and then we need two things. One is tokenizer, and then model, which we'll get later. So tokenizer, then we are going to tokenize our train, validation, and test text. It's basically, I guess you are familiar with what these encodings are going to look like. If you don't remember, I'm going to just recall, like I'm just going to show you this slide. So basically it's going to tokenize and it's going to assign an ID, right, for each word, and also assign like special tokens, right? And this is, we are converting into tensor, and this is a requirement if you want to like, so this is basic pre-processing which is required, and BERT takes this as the input format. So converting into tensor, this is going to be a standard thing which you're going to see if you fine tune anything else as well, right? That's what we did, and we have finally our data sets, train, validation, and test. Now that's all you need to do. That's the pre-processing part. For fine tuning, what you need to do is you need to define the trainer. So model, we are defining, maybe I missed that, should be, okay, yeah, sorry, yeah. So model, we are defining here, and then we tweaked some of the arguments. Some of them are changed so that it runs properly, but you can like increase epochs, you can like play around with it and see if it runs for you. And if you are using CPU and you don't want to use Colab Pro, maybe try changing epoch to 1 and see if it runs, right? And computation matrix, here we are defining our own computation matrix. We just want like all of them, accuracy, FN, precision, and recall, right? We just want to see all of that, but it's not required. You can just like get the standard evaluation as well, right? And then evaluation data set, we are giving the validation data set. Training, and then finally evaluating. So it's as simple as this, like training the model, fine tuning the model. I'm not running this right now. It should not take more than 5 minutes to run, but just to like go through this, I'm not currently running it, but you can try running each cell, or you can just go this and run all. So again, like once you have the model, you can just save it. And what we are doing here is we are saving it into your Google Drive. So it should go into My Drive Collab notebooks, right? And if you don't see the model here, there's probably a mounting issue. And yeah, so you might need to like change the path to wherever you want the model to be saved. Yeah, and you can just like do like if you have the model, like if you save the model, you can just load it, and then you can do the prediction. So it just says that this review has label 1, which is positive, and with 99% accuracy. Yep. That's it for fine tuning. It's pretty straightforward because they have like, there is a lot of abstraction. They just like the BERT model is trained for you, and then you can use any version of it, and then you can fine tune according to your task. So go ahead and play with it. If it doesn't run, don't like, if it fails, it will fail in the training step, which is here, trainer.train. Yeah, you can just try changing the parameters and see if it works. And if it doesn't, then you can probably switch to Colab Pro if you want, or you can try using GPUs anywhere else. Okay, what's the time? 10:35. Okay. Yeah, so we have some time. You can just play around with this for 5-10 minutes, I would say. Then we can switch to Doccano and we'll see how that we'll cover the last part of this tutorial, which is like how we can actually label the data set ourselves. And Sri, Danish has answered your question. I think there was a small bug. Have a look at the share and discuss channel. I'm gonna stop sharing for now. Oh, did you guys, were you not able to see my screen? If you want me to like just go through some part, and if at any point you were not able to see my screen, just let me know. Yeah, so I hope you guys had fun like I had. And yeah, there's a lot more to explore. Every slide has a link, which basically either it's a tutorial or it's a course. So if you want to go into the depth, like into more details, I would highly recommend going through the references. You can do, like right now we just did fine tuning for sentiment classifier. I have a notebook for fine tuning on NER, but we don't have time to go through it. So you can go through that, and there are a lot more. That also is like a basic example from Hugging Face library. So yeah, and for question answering, I think the link which is provided on the slide has a tutorial to fine tune. So if you're done playing with the fine tuning part, I would suggest you to go to Doccano labeling guide, because that setup might take some time for you guys. So there's a labeling guide.docx. Just follow the, like, it's basically a Docker image. So you just pull it and create the container. If you have any questions about, like, if you have any problems doing it, just post it in the questions channel. So what we'll do in the last 15 minutes is we'll try to set up Doccano and label our own data set with that. Yeah, Tanya, if you can't see the notebooks, just let us know. But it is in the general channel. That's how everyone got the notebooks. So yeah, it should be there. Okay, so I'm just gonna show you something quickly, and then so what we are gonna do for last 15 minutes is we're gonna set a Doccano server. Like we're gonna like pull the Docker image and have it running locally on our systems. Hopefully it works for everyone. If it doesn't, we are there to answer your questions. So what it does is it basically, right now we saw these data sets which were already labeled, right? But in ideal world, if you consider text, like it's hard to get, like if it's a sentiment analysis, it's hard to get like exact text, which I would call it like a labeled text. And for named entity recognition, the entities which are important to you can be different from the entities which are important for me. So this is a tool which is called an annotation tool. Basically helps in annotating the data, like labels, right? So we will be setting up Doccano, and we will be doing like tagging, or we will be annotating named entity dataset. So if you can go to this document and start with these commands, basically pull the Docker image, create the container, and start Doccano. And have this service running. So once you have all these three, I'm just gonna highlight. So pull, create. I have done that already on my machine. So you can try doing it again to show you guys. You just go, pull. Oh, one more thing. To do this, you should have Docker. If you don't, you can install it. And it's okay if you think you can't do it in like next 15 minutes, you can try it later too. I'll just show you a demo of how to do the tagging yourself. So you pull and then you create the container. Right? So since I have it running already, I can just remove it. And then you create the container and then you start. So once you start, give it some time. It doesn't come like at the next moment, right? It will take some time to load. I'll show you how it should look like. Okay, so you should get something like this, a service running for Doccano for doing like annotating your text. And we are gonna annotate a data set called WNUT. So that's also available in Slack. If you go to general, you can see WNUT.txt. That's the file we need. So you need Doccano and WNUT.txt. Now I'm gonna give you 2 to 3 minutes to do this setup, or 4, I don't know. Yeah, just let me know when you're done. I'm gonna create a poll for you guys. Doccano running. I'm gonna stop sharing, give you 3-4 minutes to do the setup yourself. And once you're done, you just vote in classroom poll, please. Yeah, Michelle, you can do it later. No problem. Yeah. I'll just show you right now and then you can try it later. I'm just going to wait for 2-3 minutes for people who are doing the setup right now. But you can totally follow this later. And also, if you have any questions at any point of the day, just message. We will be keeping track of this channel today. I understand it can be like too much to like probably download Docker if you don't already have it running and then have this setup done. So it's okay. You can just like watch me do it and then you can do it later. Okay, so we have 10 minutes left. I'm gonna start sharing my screen and show you quickly. If you have done the setup already, that's great. If you haven't, no problem at all. We you can just do it later whenever you feel like, right? So I'm just following the guide. It's pretty clear. So I just logged in, right? And then I'm gonna create a project. I'm gonna call it WNUT. Oh wait, if you guys can see my screen, I just want to make sure everyone can anyone just say yes if you can see my screen.
Yes.
Okay, thanks. So I'm going to create a project, WNUT NER, right? Project type, because we are gonna label it, it's like sequence labeling, because we're gonna label each of the word we're gonna give it, right? And then create, okay, WNUT, just some random, okay. And then we can go and select a file, right? We're gonna upload a plain file because most of the data is in plain format. It's not in CoNLL format. We'll see what that format means. Okay, so I got this, and then I can start annotating. Okay. So I have to create some labels because I have to like tell the software that what labels will I be looking for in the text. So I'll be looking for person, new label, organization, create label, product. You can just create your labels. I'm just giving something random here. What else? Okay, date, something like that, and then annotate. So begin, and then if you see anything here, so Empire State Building, oh, I can give location as well. So labels, let's give a new label, location, and just call it log and create label. Start annotating. So I'm just gonna call this as location. I'm gonna label a couple from green newsfeed. AHFA looks like an organization. I guess this is an organization, not sure, but yeah, you can, this is a date, November 5, maybe. This is a date. And then, yeah, so that's how you annotate. It will just like, it open that text file and it's opening like for each line, it's asking me, what do you want to label, right? So I'm just gonna say organization. And whenever I'm done, I can just go here and then export data, JSON with text labels. So it will give the data with labels. So I just did it for like very few entities right now, but you can do it for a lot more. And once you have this file, you can use the commands which are listed here. Basically converting it into CoNLL format, and it should look something like this. Yeah, so it will tell you that this is the location, right? Like wherever you tag, it will come here. So right now, you can probably see some discrepancies on what I tagged and what is in the file. This is because this is older version of the file. Yeah, and then you can do like a lot more with it. You can do classification, like you can you can annotate it for classification or any other task as well. And it's a really useful and widely used tool, annotation tool. Okay. I guess that's the end of our workshop. If you have any questions, please post in the Slack channel. And I hope you guys learned something, had fun. I will be taking questions for next 5 minutes, and then later in the day, whenever I have time, I'm just gonna check the channel. So don't hesitate to post your questions. Hi, Svi. I have, so like, I've always downloaded the file. There should be a way to link it to some DB, but I haven't done that. But yeah, you should be able to just get that text file somewhere. Yeah, just let me know. I'm just gonna create a last poll because I want to know what you liked, what you didn't. I hope you had fun, and good luck for your future TMLS workshops or talks. Just have fun, learn as much as you can, and yeah, stay connected. I forgot to share the last slide, I think, but you can see my email in the slide. If you have any questions or if you want to contact me, you can also reach out to me on LinkedIn. Just please provide the context, like where did we meet? Because yeah, it'll be easier to remember. I just created a last poll. If you didn't like it, just let me know. I hope like each one of you was able to learn something out of it. If you learned something, then that's good enough. All right, good luck for your future sessions, and yeah, hope to hear from you guys soon. Abhishek, I'm not sure about the recording. I know it's being recorded, and okay, yeah, I think like it will be available to everyone after the like TMLS ends.